class. We begin with a simple question. What is computer science? See, computer science is all about problem solving. We may tend to see that computer science is about computers, it's about building hardware, building software. The fundamental thing is developing correct and efficient solutions for a problem. If you look at the history of computer science, you can see that the quench for solving problems, that was a real root of computer science. So we have to arrive at a problem. We should articulate that problem. We should design a solution for that problem, and later the problem will be implemented. Once we implement that, it has to be correct and efficient. We can classify the entire computer system into hardware and software. By hardware, we mean the physical elements of the computer. Whatever you can touch on a machine, it is hardware. Right from the nuts and bolts to the most complex thing and the most important entity on hardware side is CPU and the motherboard that houses the CPU. Everything is part of hardware. Every physical element of the computer is called as a hardware, and you can see that few of them are listed in this figure. So how these components will work as a single unit? It is with the help of software. So without software, a system will not exist. Now, what is software? A software is instructions that tell the hardware how to perform a task. And interestingly, here software does two roles. What is that? One, it has knit together all these components. See, all these components are now, it is physically connected, but they have to work. When we touch on the keyboard, something should happen. When we click on a mouse, something should happen. So whatever we instruct, we command to the system, there has to something should happen. We don't like saying that hardware is not there, say hard disk is malfunctioning, net connectivity is not there, please check the cable. All these things, whatever we instruct, it is being done almost automatically. How this magic is being done? It is being done with the help of software. And software is also called as programs. Here, now we take a diversion. We speak about a particular kind of software now. See, software can be even now broadly classified into application software and system software. There, our machine will become in the inner circle. It is called as a bare machine. So a bare machine will be having a set of hardware components, CPU, disks, mouse, whatever you name, it is there. The physical elements. It is housed with a system software. System software is, you can see that it is close to the hardware system. And one example is operating system. We can say that a OS is a system software that relinquishes the control of a machine for an application software temporarily. Once the application software is done with the task, this OS will regain the control of the system again. We double click on MS Word. MS Word will be activated. MS Word app will be given a lot of resources. Once the MS Word is quit or it is closed by the user, whatever resources granted to that application will be regained. Then it will be given to some other system. It is like a government. So operating system is a part of system software. Now, this software can be classified into instructions given to a computer can be broadly classified into system software and application software. What are the system softwares that you have seen? Of course, OS is on the one side. So we have these two kinds of category. How can we name them? if someone asks us, what is the difference between application software and system software? Application software and system software. So we can see that there is an end user in every system. See, you may be watching this, listening to this class using your mobile. I'm using my laptop. Both of us are end users here. Whatever might be a device, we had a purpose now, and we are using the resource of the system. So an application software is designed for end users. We may prepare our class notes. We may watch a video as you see now, a live session, or you may hear an audio session. You may browse internet. So all these are tasks that are done by the end users. So whatever the task to be done by the end user, one application will be developed. It can be Excel, say, to create some spreadsheets. It can be a text editor to create our program, PowerPoint for creating our slides, audio recorder to record our audio. You name it, it will be there. Now, application software will be closer to the user. The beauty of the application software is that the intricacies of the hardware and the entire system is hidden. The complexity of the hardware is hidden from the end user now. End user will come at this side. He will make use of any of these things. Instead, application software will be constantly in touch with the system software, especially with the operating system, to get the things done. And I hope that you might have learned about user mode and kernel mode. Two modes of operation for any system. Normally, every application software will be working with the user mode with less privileges. Suppose that we want to open a file. It is an activity that requires higher privileges because secondary storage device will have to be accessed. System will have to check whether there are enough space for that. System will check whether the user will have enough rights for that. Based on all these parameters and circumstances, there has to be either an accept or reject. This task cannot be done by the user. If every user becomes admins, it will be the total ruin of the system. So temporarily, application software will demand for certain services to OS. OS will take charge of the entire system. OS will go to kernel mode. In the kernel mode, OS will do all these things interacting with the hardware. Then the results will be fed back to the application software, and mode will be switched again to user mode. And this is how the system works. Now, what about system software? System software is concerned with how to manage the entire hardware and the entire computer system itself. Whatever happens on the system, it will be with the knowledge of the system software. System software is responsible for running the entire system. And you can see that it is this layer that gives a platform for other softwares to work. They cannot directly interact with the hardware. There has to be an interface. So if you look at the definition for OS, if you are asked to define operating system, you can see that there are at least half a dozen definitions for OS. One definition is its interface between user and the hardware. And OS is a part of system software. Now see here, low-level programs. What do you mean by level of programs? We have learned about high-level programs and low-level programs. What is meant by this high and low, these adjectives? When we say high, we know that it is closer to the user. A programming language like C, it is like English. Why it is done so? Because every person cannot be a master in computer hardware. He will not know about how the address is being done in primary address. What are the range of memory allocated to the OS? All these things cannot be known by every user. So, and every variable is a memory location. So all these things are represented like a natural language in C. So C is called as a high level thing. When you say low level means it is we are closer to the machine architecture. As in the previous example, opening a file in C, it is as easy as F open. But within F open, there are many tasks that are being done by the OS. OS has to perform the low-level task of accessing the specified secondary storage device. It will check for availability of space, and it has to create a file in certain location. Details of the files will have to be stored, say, in a data structure. Then the return status will have to be given back to the application software. So all these low-level programs will be done at the basic level. It will be done by the system software, whereas application softwares will demand for that. We will provide. So in C, we know that in C there will be functions like printf, scanf. Printf will manage output devices. Scanf will manage input devices. So all these are our functions that becomes on the outer layer. Internally, these devices are to be accessed, and the results will have to be fed to the app software. And that part will be done by the system software. Now, these are the type of system softwares: operating system, compilers, assemblers. These are all called as translators, linkers and loaders, file management utilities, and device drivers. So these are all different kinds of system softwares. What is an operating system? We have already learned. What about compiler and assembler? We have compiled a lot of programs now. Compiler is a translator. Compilers and assemblers will come under the big umbrella of translators. Linkers and loaders, we have separate units to discuss about that, and we'll discuss in detail about that. File management utilities: creation of a file, searching for a file, loading the contents of a file, updating a file, deleting a file. So all these things will come under that. What about device driver? We know that our machine has got several devices. Say we plug in a USB, something has to happen. So mouse is there, keyboard is there. Every device will have some kind of interface. So the device drivers are programs that specifically helps us to operate and control a specific device. Now, see in this section now, you may face questions like define system software, differentiate between system software and application software. So how to differentiate between these two? So these many points we can note. So first thing we have already discussed, a system software will be closer to the machine, whereas an application software will be closer to the user. This part we have already discussed. And we can see that a system software is always machine dependent. Why? Because system software will interact with the hardware. Intel machine will be having a specific architecture, and that may vary from one CPU to the other CPU. So that is clearly depending upon the hardware. Whereas yes, an application software can be machine independent. We can generate an app which will work for on all machines, platform independent applications. System software will interact with the hardware directly, whereas an application software will also interact with the hardware, but it will be through some system calls, kernel calls. System call are SOS messages to the operating system given from the application software. So we know that when we do something, see, we write a program and we say enter the prime number, enter a natural number. I say 17 and your program responds that it is either a prime or not. There, as soon as a keyword, some value is keyed in, system is reacting. We have not written anything for that. Instead, we'll make use of printf and scanf for that. Within printf and scanf, there are systems calls, low-level system calls, which will access the keyboard, which will access our output devices. Now, what about a system software? A system software is a general purpose software designed to use the hardware resources. It is generic. Any kind of application can be installed on a machine and it will work. What about an application software? It has a specific purpose. Word processor will help us to do word processing. So every app will be having a specific objective, whereas system software has the generic function of managing the entire system. Now you can also see that a system software provides a platform for running apps. It is not running on its own. Say a compiler will not run on its own unless we ask the service for a compilation. At that time, it will come into action. But it will be there in the system as such. What about a system software? A system software cannot run independently. It needs the presence of, every app needs the presence of its system software. Now, I told you that OS is like a government. It runs in the background. It comes to the foreground as and when the situation arises. Similarly, every system software runs in the background. Any user will not interact with it directly. It is done with the help of apps, application software. So user will interact with the application software. Application software will demand for the system software for any kind of service. System software will do that service and return the result back to the application.